Let fx equal to defined by this structure and x is coming from closed interval this. Then which of the following is true? Maximum value of fx is 3 by 2, minimum value of x is 1 upon 3, maximum at half and minimum at 1. Means four options are related: maximum value and minimum value at a point, or maximum value at a point. Means minimum value and minimum at a point, maximum value and maximum at a point. These four types of options is given to us. As fx is 1 upon 1 plus mod x plus 1 upon 1 plus mod x minus 1, and this is true for all x is coming from closed interval -1 to 1. Whenever absolute function involve, then always break absolute function at that point from which behavior changes. So we know very well at point absolute value changes. So fx can be written as for positive and negatives. Means whenever x is less than 0 and greater than -1, because of -1 is the left bound of this interval. So fx will be 1 upon 1 minus x plus 1 upon 1 plus of x minus 1. It is for negative value, means for negative value this is also negative, so absolute value is minus of x, and it is also so minus of minus x it. And for positive value, so first is, suppose this is for negative value, so I can write 1 upon 1 minus x plus 1 upon 2 minus x. This is for negative x. And for positive value, means x is greater than equal to 0 and less than 1, so it will be 1 upon 1 plus x for positive value plus 1 upon, this is again 2 minus x. So I have this function, this is my fx. Now f dash x will be derivative of this one will be minus of 1 minus x derivative and again positive, so 1 upon 1 minus x whole square plus 1 upon 2 minus x whole square. This is the derivative for negative x, and for positive x it will be minus of 1 minus 1 plus x whole square plus 1 upon 2 minus x whole square. This is for positive x. And I left at 1 because I didn't take at 1 because of function can change at boundary points. Function can change behavior at boundary points. So I left this 1 at interval. So I define f dash x at -1. So you can remove this one inequality also, means -1 to 1. This is so at 0, at this point is 0, this value is 1 upon, so -1 plus 1 upon 2 square, it means negative. So at 0 f dash is less than 0. F dash x is less than 0 when x equal to 0. But uh, we surely have the conclusion, or we have conclusion for positive, sorry, for negative function is increasing. For negative x, we know function is increasing because of this is positive value always. It means minimum value, minimum value because function is increasing, because function is increasing from -1 to 0, like this or this way. It means minimum value will exist at this point. If function have the same behavior, means monotonically behavior, then function have minimum value at -1. And this options D is saying minimum value of fx occur at x equal to 1. So this is false statement. If function have minimum value at -1, then value of the function at -1 will be 1 upon 1 minus of -1 plus 1 upon 2 minus or plus 1. You can write. It means 1 upon this is again 2 plus 1 upon 3 means this is not true. Minimum value of fx is 1 upon 3. This is false statement. Means we have two remaining options A and C. Maximum value of fx is 3 by 2 and maximum value at half. So we all know function is increasing for this point. So consider function is increasing. Function is increasing or say monotonically over the closed interval -1 to 1. If it is increasing, because half part is increasing, so I consider or let function is monotonically increasing on the entire domain. So if it is increasing, then value of the maximum value of the function is at 1. So max value will be at 1. So 1 upon 1 plus 1 plus this, it means 1 upon 2 plus 1 equal to 3 by 2. So maximum value of the function is at 1 and this is equal to 3 by 2. So option A is correct.